So the initial problem that we were facing is the engineers that designed the LRT rail that went into Grierson Hill, they overlooked the fact that they needed to attach black topsoil on this very steep hill. And how were they going to keep the black topsoil on the slope in order to vegetate it back to the original status that it was prior to them disturbing it?
They approached Mark, our president, and he asked me if I could go and look at it. I went to the site, looked at it. Some of those were really steep. What I saw at the site was in excess of 60 to 75 degree, even more maybe, right? But erosion, the only way we could control the erosion of the surface soil was providing a cellular confinement for the material that we, topsoil or material you put on top so that the vegetation can grow.
So with Wilco, they were looking for a solution that would be a long-term solution, something that they didn't have to put too much effort or money into. And we basically gave them the solution that not only protected the slope, but met their timeline. What Paradox had to offer to solve the problem of the high degree of slopes and holding material was our ToughCell product. It's a geocellular confinement, which is basically we take the soils and we confine all of those soils into smaller pockets that are a little bit easier to hold in place. It's a very simple to deploy material that it comes all condensed and compacted, and we just stretch it out and use that as the base to hold the infill.
Once the material was in there, it would get confined and it would hold it on the side of the hill until it got vegetated, and then the root systems could embed it and then anchor itself into the side of the hill naturally.
Before this job, I'd never worked on a slope before, especially one of this magnitude. I wasn't even aware that this was a ToughCell application until I actually got the call. So without any knowledge or prior training, we learned to harness on site day one, and the rest was trial by fire.
This project needed to be done. We started in September. It had to be completed before the snow was flying. We were looking at a maximum of 2 months, and I believe it took us in the neighborhood of 1 month to 5 weeks to complete the project.
Once I saw the project, knowing that we had to engineer it on top of it, which takes a lot of calculating and a lot of effort from an engineering department, we knew that we were already running into trouble with timelines. And so therefore we instantly, I think I got the phone call on a Thursday, and the engineering team worked all late into the evenings, all weekend, to have an engineered solution by the Monday morning.
We had to review the documents, whatever was available, go to site, get a survey data. Our team had to go do the drone survey and mapping and everything. And that's how the client just accepted our proposal, looked at it, and they were happy to see like, oh, this design works. 2 or 3 of our engineers were involved in this one. This design, including myself as a reviewing the design, and Argia, our engineer manager, he designed it for slopes and all those things. So we needed data. There was some data were available, but not everything.
And then of course, once we got on the job and everything started rolling, the engineers had specific spots where anchors had to be put in place, and we couldn't put them in because there was a lot of stuff, that unknown material that was buried underneath the ground. So all this was done in an amazing team effort where each department was working with each other, coming up with solutions and value-add solutions, at the same time considering all the safety features that we had to put in place for the people doing the work, and on top of it to make sure that that slope didn't slide off the side of the hill come spring when there's a huge moisture load on it.
There was quite a large portion of the topsoils that we were trying to revegetate that would be directly above the LRT railway. Had there been any kind of failure, all of that material would have been on the rail. And because of some of the challenges that they faced, any extra undue hardships would have been pretty detrimental to not only our project but the whole LRT line itself. ToughCell is pretty unique in the material that it's made of. In Alberta, our climates are very heavy with the freeze-thaw cycle. We use a nealloy product in the ToughCell, and nealloy is a very stable product that it resists stretching in the heat and it doesn't get brittle in the cold. So on this slope it was essential that we didn't have any stretching, which of course would cause a failure, and the brittleness as well. It would, had that material broken, then the slope would have failed for sure.
In the end, it turned out to be the best solution, the only solution that they could find to solve the problem. So we were just happy to be there to assist and overcome the challenge.
To go from something that was initially intimidating and seemingly impossible to a completed project in a matter of weeks would make satisfied sound like an understatement.
Oh, it's already been 2 years. It's staying there perfect. The slope is still looking good, stable. We have peer-reviewed paper already published, and we will be writing something more on this because as we go, we have been monitoring it.
I'm very satisfied with how it turned out. We had everything execute extremely well. The soils were placed exactly as they should be, and when you look at it today, the vegetation is really taking hold and it held up extremely well. Whether it's native vegetation, new construction, we can help out.
If you ever have any difficult challenges with soil stability, call Paradox. We got you covered.